Hello guys, you're welcome to another video. Now in this video we're going to be taking a look at how to decode and playback video using the FFmpeg library. So in the last video in this series I showed you guys how to decode and playback audio using FFmpeg. So in this video we're going to be taking a look at the video counterpart. So how do we do this? Well, the first thing we're gonna need is something to create a window for us and render something on the screen. So we're gonna be using SDL2 for that, and so I'm going to paste in an SDL2 code that is going to create and render the window on the screen. And because the purpose of this video is to take a look at FFmpeg, so I don't want to spend too much time creating and setting up the window. So this is the entire code for creating and setting up the window. I've already written it. So as you can see, the first thing I'm doing is I'm including the SDL2 header file, and here I'm also including a mutex header file because we're going to be using a mutex to synchronize this struct here. Now you can see that I'm creating an app window in the global scope here, and the reason I'm doing this is because I want to make this tutorial very simple. Like I said, I want this to be about FFmpeg and not about best practices and stuff like that. So if you want to create an actual application, you're probably going to put this app window somewhere that is not in the global scope of your application, but for this video it's actually fine. Alright, so you can see we have a function here that says init window, and this is where I initialize my SDL window. So I call SDL init to initialize the SDL subsystems, and then I create my SDL window and say that it's going to be 640 by 480, it's going to be centered. The title is going to be FFmpeg video decoding, and I want the video to show as soon as I've created it. Now I also created an SDL renderer here. And as you can see, it's the renderer for this window that I just created, and I want it to be a hardware accelerator renderer, and of course whatever this is, present vsync. Okay, so you synchronize the renderer with the vsync of the display. And here I'm creating an SDL texture. So an SDL texture is representative of a hardware texture. So if you're thinking in terms of OpenGL, so this is representing an OpenGL texture. So I created texture for this hardware accelerator renderer. I set my pixel format to be RGB565, and I set my texture access to streaming, and I set my width and height to 640 by 480. So we're going to be changing the width and height of this texture in a minute. But before we get into that, I just want to explain. So here the texture is for this renderer, this hardware accelerator renderer, and here I'm saying that the pixel format for this texture is RGB565. So what does that mean exactly? The pixel format is simply saying we want 5 bits of red, 6 bits of green, and of course 5 bits 5 bytes, I guess it should be bytes. Anyway, so RGB565 is what I want to use, and I'm using RGB565. Yeah, that's 5 bits. So each of these are actually bits, I believe. So if you count this, it should be like 16 bits or thereabout. This is 11 plus 5. Yeah, that's 16. So this is 16 bits per pixel, I guess. So the reason I'm using RGB565 is because, first of all, it's not that bad for a color format, and second of all, this is the less this is the less ambiguous pixel format I can find in relation to SDL and FFmpeg. SDL and FFmpeg both support a lot of pixel formats. So for example, you could find RGB888. I don't know the difference between RGB888 and RGB24 or RGB8888. So there's a lot of variations of the RGB, so I'm just going to stick with the RGB565 in this video. So if you know the pixel format you want to use and you don't want RGB565 for some reason, you can change that. And then we have this SDL texture access streaming. So the texture access streaming is simply saying that we're going to be modifying this texture a lot, and we're going to be doing that a lot because as soon as we decode a video, we're going to render it on this texture. And of course, we set these to a temporary 640 by 480 because we have to initialize our texture with a size. And then of course, we set that to our global app window so that we can keep a reference to these objects. And then in our draw, we have a draw function here, and you can see that we have the SDL set render draw color. We set it to white, and then so this is where we're gonna draw the texture, and I have a mutex inside of my app window structure that I lock so that I can access, I can update this texture here. I can render the texture here, and I do the same. I unlock it once I have rendered the texture. I clear the screen and I render the, this is what I should do first. I should clear the screen, then copy the texture to the renderer, which means I'm rendering the texture to this renderer to the screen, and then I'm unlocking my mutex because I'm done. I need to take this here, right? And then I'm rendering the of course the render. So I'm saying SDL render present, which is going to take the renderer and put it on the screen, and we're gonna see what we just rendered. So that's all about drawing and creating our window. Now of course, cleaning up, we just gotta clean up SDL and quit the application and delete the application window object. And here, so in our main function, which is the entry point of our program, we're calling our init window, creating an event loop here. So we're saying just while true, then we're going to poll for event, and if we get some sort of event, I believe this should be something like, because we could not have event, for example. So here we have if SDL poll event. So if we're able to get some events, then we determine if it is the Q key was pressed on the keyboard, or we try to close the application. Then we want to break out this loop, and then we want to clean up, and then we want to return. And that'll be all for this. So what I want to do is I'm also going to add a delay. So as you can see here, once we have polled, we also draw to the screen, which is what calls this draw function here, and that renders our texture to the screen. And one more thing is that I'm going to have a delay here, which is going to just wait for like, I don't know, 30 milliseconds, so that we don't use up our entire CPU, while just trying to run on this loop. So we're gonna wait for 30 milliseconds every time. I think 30 milliseconds should be good enough. Now, with that done, I'm going to compile and run this program here, and I'm gonna do that with this G++, blah blah blah. So this is the file name, test FFmpeg video, and then the output is going to be test FFmpeg video. We're gonna link to the SDL2 library, AV codec, AV format, and AV util. Of course, you should know how to. You should have FFmpeg installed, and you should know how to link to these libraries. And of course, you should have SDL2 installed. So if you build this project right now just by compiling with G++, you're gonna get the test FFmpeg video binary here, and you can run it. And when you do that, you're gonna see this screen here, and you're gonna see the window showing up as you expect. And you can close that to start working with FFmpeg. So the next thing I want to do now is to import the FFmpeg live header files. So we're going to use the external C because the FFmpeg libraries is predominantly a C library, so we have to wrap it in this external C because we're working with C++. So I'm going to take the libav format. I'm going to import AV format. I'm going to import the AV codec. Alright. I'm also going to need AV util, and of course I'm going to need the SW scale library because we're going to be doing some pixel format conversions, so we're going to be using the SW scale library to do that. And what is this? So it says this AV codec not found. Yeah, that's because we needed .h at the end. And now we have our import files. we've added our include for our imports, and now we can start working with FFmpeg. So the first thing we need to do is to add a couple of things to this app window structure. What we're going to add is we're going to add the AV format context. And the AV format context is what stores the information about the mixer, right? We're also going to need information about the decoder, so we're going to store an AV codec context. Codec context, just like that. So now that means that we have to create and initialize our format context and our codec context here. So to do that, we're going to do our app window format context equals to AV format open. Okay, we're not gonna do that. App window format context is equal to null pointer. Make sure you say that's a null pointer, because AV format open input is going to take a reference to the address of this format context. So we're going to do if AV format open input, which is going to take in the app window format context. So it's going to take an address to the pointer of this format context. We also need to specify a URL, which is a path to the video file we want to play, and then we need to specify an input format, which we don't have. So we can specify null or null pointer. Some dictionary options, we don't have some, so we don't have any, so we're going to specify that too. Now if it returns anything that is less than 0, that's an error, and we're just going to abort the program. Right here, we're going to blindly abort the program. You could do some error handling here if you want, but I'm not going to do that. Alright, so let's make sure that we have a file to give to AV format. I'm going to check one of my videos, one of my recordings. So I have I'm just going to take this photo of this view widget video, and I'm going to put it inside of here. You can take any video file you want, it doesn't matter. FFmpeg supports a lot of video formats. In this case it's just MKV, but like I said, it doesn't matter. You could take MP4 if you want. I think I have an MP4 here, so if you want to use that as an example, we can use that too. And so now that we've done this, the next thing we have to now do is to call AV format find stream info. So AV format find stream info, and this is going to help AV format look for information about streams inside of your inside of this file. So if it opens the input here, it may not have enough information to determine the amount of streams inside of this file. So AV format find stream info is going to help you look through this file and get all the stream information and metadata. So once you do that, you're going to now need to pass in the format context, and this is going to be app window format context. We're going to need some dictionary, and we don't have any options to pass. We also want to check for error, and if there's an error, you probably want to print an error message and close the program, but I'm going to abort in this video. Now this isn't the best way to do things. You should definitely print like some error messages out there to see what's going on, but just to save time, I'm not going to do that. Alright, so the next thing I want to do once I found the stream info is I can actually dump the stream info. So we can do AV format dump, I think it's AV dump format, exactly. So we want to dump the app window format context. So we specify the index we want to drop. We don't really care about index. The URL, so we should put the URL void just. His output is asking if this is an output format. This is not an output format. We want to dump the input format, so we're going to say that is 0. And just to make sure that everything we've done so far works, but before we do that, I'm going to go to the cleanup now, and I'm going to clean up my information, my AV format stuff. So AV format close input, and that is going to be app window format context. Now AV codec free context. Make sure you free the AV codec context. We haven't looked at the AV codec context yet, but we're going to do that pretty soon. So I'm going to comment this out because we haven't initialized this yet. But if we compile and run the program now, let's see what we get. Let's see if we actually get to the point where we are able to dump the format and print something out on the screen. Alright, so if I do this, if you look here at the logs, you're gonna see now that it prints some information about the format, just like something you would find when you run FFmpeg. Alright, so it's gonna print information about metadata, like the duration of the file, you know, the number of streams you could find. For example, you can see it has an audio stream and a video stream here, and so that's how you would basically see information about it. And now if you want to access the information stored inside of here, or that is dumped inside of here, the way to do that is to access this format context. So in this case, you can see we're dumping the format, no problem. So the way to do that, like I said, is to do format context, and here you can find the streams. And so this is where you can also use the number of streams, for example, to find whatever information you're looking for in regards to that. Anyway, so I want to look for the video index. Alright, so what I'm going to do is so each stream inside of my video file has an index. So for example, the video index might be index 0, the audio index might be index 1, depending on the number of streams stored inside of this file. Alright, so I want FFmpeg to give me the best video stream inside of here, and there's a function to do that. It's called avFindBestStream. Alright, so the best stream is, like I said, the best stream for the particular you know, format type, like video or audio. So app window format context, just like that. Now it's asking for media type. Here we're going to pass in the AV media type video, because we want video. Wanted stream number we do not know, related stream we do not know. Now this is a decoder read, so this is telling us that if you want the decoder structure to be returned, you need to pass in an address of a decoder pointer here. So we're going to create that AV codec. Make sure you initialize that to null pointer, and we could pass in the codec here. So this is going to work. And now flags. So we don't know any flags to pass in, so we're just going to say 0 at this point. Alright, now if video index is less than 0, then I'm going to abort the program again, because it means that FFmpeg didn't find a video index inside of this file. There is no video inside of the file according to FFmpeg, so we don't have anything to do, and I'm going to abort the program. Now we're gonna, once this passes, then it means we have a codec and we have a video index. Alright, so what I'm gonna do is go back here, and I'm going to add video index just like that, and I'm going to have to initialize my index equal to video index. So I'm going to have to initialize my codec context now, and we're going to do that using app window codec context, AV codec alloc context 3, and then we're going to initialize it using the codec we got from here. And now we're going to check, if not, app window codec context. Again, I'm going to abort, not the best thing to do, but I'm doing it. So once you're done with that, we want to copy information to the codec. So the codec context is what stores information about the decoder, the information the decoder needs to actually start decoding, or the video frames in this case. Alright, so we need to give information to the decoder. So how do we do that? We need to copy information found inside of the stream to this codec context, and to do that we use what is called AV codec parameters to context. So it looks something like this. And so to give to the codec, we're going to say, so the codec context that we want to give is the app window codec context. And the codec parameters we want to get, we're going to get that from the app window, format context, streams, and we're going to use the video index to access. So we're saying that we want the stream at the video index, and of course we're going to need the codec parameter. So the stream structure inside of here actually has a codec parameter which stores information found about the codec of the file. And so once this happens, we've copied information from this codec parameter to this context. Now you should probably check for error, because this method can actually return something like a result that is less than 0. So if you check and you see that this result less than 0, you should definitely handle it, because it means the operation was not successful. So once that is done, the next thing we have to do now is to open our decoder to start decoding. So we're going to do avcodec open 2. We're going to do app window codec context, and the codec we want to open, we have the codec structure. I don't have any options, so I'm going to pass that in. I'm just going to check for the return type, the return value here, and say if return value is less than 0, I'm going to abort again. Now, because I've been aborting a lot here, let's just run the program and see if this actually works. So here I'm going to run again. There is no error, nothing crashes, nobody aborted, so we're good to go. And as you can see, the codec was created here, and now we're leaking memory in cleanup because we're not doing this. So I'm going to make sure that I comment this out to clean up the codec context at the end of the day. So I have so in this case now, this code is run, and I have successfully opened up the decoder. So the next thing we have to do is to start feeding data to this, to the screen and start decoding the stuff. So the way to do that is really, really simple. We're just going to create a new thread, and we're going to decode on a new thread. So that's how I want to do it. Let me see if I can. So I'm just going to create a function here that says start decoding, right? So start decoding, and so I'm going to create a new thread. Actually, the start decoding function is going to run on a new thread, and this is how I'm going to do it. What do we have here? Okay, I need to include a thread, I believe. And now to use this, the start decoding function needs to be at the top. I really forgot C++'s. Anyway, so start decoding needs to be here for this to actually work, but we're going to create a new thread anyway. And we're going to need to put a thread instance here. So just like that. And now we're going to come here and say app window thread equals to std thread. If I can create a new thread, and now let's check what are the arguments. So we're going to just put the start decoding here, not like that, just like that. I believe this should work. What do we have here? We get an error. std thread. What is this? Let me see if this works. Instead, nope, it doesn't work. Should I use lambdas here? I think I should. That should work. Then I can call start decoding something. And this still doesn't work. Alright, so what I'm gonna do is I'm going to try to build this and see if this actually builds. Alright, so this looks like it's going to build if I link to pthread here. I don't know why the error is showing up if it's gonna build. Anyway, So this is actually built. So what I want to do now is to start decoding inside of here. So inside of this start decoding function, just to make sure that this actually works, we're going to do, because we don't want to care about this thread, actually we might want to care about it, but the thing is, inside of the start decoding function, I want to run, I want to just print something out on the screen. So I'm going to do printf, and I'm going to say decoding, for example. And now, if I run this program now, if I compile and run this program, once it prints out this decoding function, the program should terminate. What is this? Do you need map? I don't know. DSO missing from command line. I have absolutely no idea what that means. I thought I compiled this just a minute ago. Like, oh yeah, I didn't put the thread in there. Right, so now, so I need to run test FFmpeg video. So I'm going to do just like that. And now you should see, okay, the coding is printed here on the screen, but interestingly enough, the thread didn't terminate. Wow, that's crazy. Okay, terminate call without an active exception. Yeah, so it was supposed to terminate, but I didn't know what happened. Whenever you spawn a thread and the function that is running the new thread, is done, it's going to terminate the application. Unless you call the thread.detach. So that's what I was looking for. So you could call something like thread.detach, and now it's not going to happen again. So the error we're getting since we've detached the thread now, is not going to exist anymore, and the application is going to work fine. This can close. There we go. So now that we have decoding running here, this is where we're going to be doing all our decoding. So the way to do that is simple. We're going to create we're going to create a packet, okay, and this is going to be AV packet alloc. Alright, so we're going to allocate an AV packet, and then we're going to do frame AV frame alloc. Now I'm just going to say AV frame so that you guys can actually see the type. So there we go. We've just allocated a packet and frame. Make sure you check for null, because when you try to allocate them, if there is no memory, then of course it's going to return null. So make sure you check for that. And the next thing we're going to do now is to start reading stuff. We have our video index inside of app window, so we don't have to worry. So we're going to say that while AV read frame, alright, I believe that's as much as we need. Yep. Nope. So AV read frame, we're going to read into the app window the format context. We also need to pass in the packet. Alright, is greater than or equal to 0. So if it returns a value that is less than 0, then it means that there are no more frames for the demux or the read. Alright, this is not a dot. I don't know why I keep confusing C++ and Rust, or I don't know. I guess I'm getting used to Rust. Anyway, so you can now see that we're trying to read a frame for the format context into this packet. So now we've read a frame. If we're inside of this block, then we've read a frame. Now we need to know what kind of string we're reading this frame from. So we're going to do if packet string index equal to, or we just say does not equal to app window video index. So we're only interested in the video stream, no audio in this video. So we're going to just continue. So we don't want to care about the we could also do AV packet on ref, and then tell it to free the memory that is referenced inside of this packet. But this isn't actually necessary, because when we want to read a frame again, the data inside of the packet will be unreferenced anyway. But we can do that ourselves, it doesn't matter. So now we've actually gotten a frame that is our video frame. Alright, so now what can we do with the frame? We're going to take that frame and send it to the decoder. So the way to do that is simple. We're going to do int return. We're going to do avcodec send packet. Alright, and this is going to be the app window codec context, and then we're going to send the packet over. So we're going to say that I'm going to put this inside a while true loop, because I'm going to explain that why in a minute. So this is going to be while true, and here what I want to say is that I want to keep working with this packet. I want to keep sending this packet to the decoder until the decoder has gotten the packet. Alright, so here if it equals, so if the return value is greater than or equal to 0, if we get a negative results, then an error occurred. So I'm just going to say okay while we're not okay, and here, so if red is greater than or equal to 0, okay is true, I guess, yeah. And now we could continue with receiving frames. So red can be avcodec receive frame. Alright, so what I'm trying to do here is simple. I've sent the packet to the decoder, and now I want to receive a frame. Alright, basically I've sent the packet to the decoder. I want to check if there's a frame, and I should actually put this inside of here, because we can receive multiple frames just by sending one packet. Alright, so this is going to be greater than or equal to 0, and we need to do the app window codec context frame, just like that. And now this gives us what we need. We now have our frame populated with data. Now what we could do at this point is to give the stuff to this SDL texture, which I'm gonna try to do right now. I hope this actually works. I don't know if I can reference this texture on another thread, but I hope that actually works, like I said. So let's just give it a shot. If it's not possible, we're gonna create another structure that is going to let us, send the frame to the texture instead. All right. So what we're gonna do now is we need to convert the frame from whatever format the decoder has given us into the RGB 565 pixel format, because if you remember, we're using the RGB 565 pixel format here, so we need to do that. So how can we do this? This is actually really simple. We need to use the SW scale library. All right, so we need to add I'm just gonna put it I'm gonna put it here. So we need something that is called an SWX context. I'm going to call it rescaler. So to create a rescaler, we're going to go back to where we're initializing stuff here. And now we need to read something from here. So once we have taken data from once we've opened the codec context, we can fetch the format that the codec is going to give us as an output from here to work with the rescaler. So basically we're going to do app window rescaler equals SWS get context. Alright, so it needs the source width. So the source width is basically the width of the of course source width. Anyway, so the width of the original video or video frame. So we're gonna get that from app window codec context width, just like that. App window codec context height, and now it needs the source format. We can also get that from the app window codec context format. FFmpeg, that's what it's called, pix format, and the destination width is the same. I'm just gonna go ahead and go copy this because it's a little bit long to type. So the destination width and the destination height is the same. We don't want to change that, but if you want to change the destination width and height, you can do it here. Now the destination format, we're going to use AVPix FNT RGB 565. So this is where we're going to specify the new pixel format that we want. Now we could specify flags. So I'm going to do SWS by linear, or I could do by cubic. It doesn't matter. I don't know exactly what this does. So source filter, we're going to happily put null pointer here. The destination filter is going to be a null pointer, and we don't have anything to put here, so we're just going to put a null pointer for the params. And that should initialize our rescaler. Now, of course, you should check to make sure that this actually works as you might expect. And if it doesn't, well, anyway. Right, so we're going to come back here, and we're going to now create a new frame. I'm going to call it out frame, and we're going to do AV frame alloc. You could actually create this frame outside of here if you don't want to have to keep allocating a new frame. I think I'm just going to do that quickly. Here we go, and we now have our out frame here. So what I'm going to do now is I'm going to say my out frame's width is going to be equal to the frame's width. My out frame's height is going to equal to the frame's height, and my out frame's format, I believe, is going to equal to AVPix FMT RGB 565. I believe. There we go. I could also copy some other things like I could also copy the PTS, which is a presentation timestamp. We're not going to be using that in this video, but this is actually useful for a variety of in a variety of cases. For example, to synchronize your video to make sure that it plays on the with the right frame rate. But anyway, so you set the PTS like that, and a bunch of other parameters you can set, or you could just do, for example, AV frame copy and copy props. All right, so it's going to copy to the out frame the frame. All right, but I'm gonna move this up here because once I copy, if it copies all the properties, I want to change not the width and height. Basically, I want to change the format for this. And now we can do AV frame get buffer. AV frame get buffer. I think that's what it's called, right? Yeah, that's what it's called. So give it the out frame, and the align is 0. So what does this do? It says, as you can read here, it says allocate new buffers for audio or video data. So the following fields must be set on the frame before calling this function. So the pixel format for video. If it's an audio, you must have set the sample format. You must set the width and height for the video. So basically, you have to set the width and height for the video and the pixel format, and it's going to help you allocate the buffer data, enough buffer data to contain this frame. All right, and like I said, you could certainly do this outside of here, but I'm just gonna pretend like I don't know the size of the frame, so I'm gonna put it here instead. Actually, you know what, for performance sake, I'm actually going to take this out. No, I'm going to leave it in. Anyway, so make sure you check for the return values of all these functions to make sure that they don't return a value that is less than 0, to make sure that your program stays valid. And once we've gotten the buffer, the next thing we want to do is to call the SWS scale. All right. Now, of course, it needs the SWS context, so we're going to say that app window scalar, just like that. Now, it needs the source slice. So the source slice is basically the data that the frame, the original frame, the data pointer, and the data pointer lives inside of frame data. All right. The source stride the data also lives in frame line size. All right, so you don't have to do much. the source slice y is 0, and the source slice height is actually frame height. All right, and now it needs the destination slice. So the destination is actually the out frames data, just like that, and the out frames line size. And with that, you have successfully given SWSKill enough information to be able to give convert these frames and put everything inside of out frame. So I'm going to do auto read. Okay, I have red inside. Nope. Red. Result. I'm just going to say result. All right. So now I'm going to say if result is less than 0, which means if the scaler fails, I want to abort from here, right? Or just to make sure that I can actually see something, maybe I can do a cert, and then I'm going to include assert. I'm going to be able to assert that this is false, and then it's going to just show me the line where the stuff happened. What's this? I'm just going to just do circle H. I don't know. Yeah, there we go. Anyway, that seems to work. And now that seems to not work anymore. Alright, this is amazing. I'm just gonna keep it as CSR anyway. So this means that now we have our data stored inside of this out frame. Now we have a bunch of things that we've allocated here, so let's make sure to free them once we're done in this while loop. And we're going to do that here by doing AV frame free to free up our frame. We also need to free up the out frame, and of course we need to free up our packet. And just like that, that is how you free up these 3 structures we just allocated here. And before I forget, we also need to free up the rescaler. So let's go to our cleanup, and we're going to do it here, SWS free context, and we're going to say app window rescaler, just like that. And that is going to free up our rescaler. And if we go back here now, we've gotten our frame. Now we have to give it to the SDL texture to display it on the screen. So to do that, we're going to say lock the mutex, lock the texture, copy the data, unlock the texture, and unlock the mutex. So to lock the mutex, we could do these 2 steps, this and this in one line, by just using an std unique lock, right? On our std mutex, and then call it lock, which is just going to lock our app window mutex. All right. So what this one is going to do is that once this scope is over, once this block goes out of scope, the mutex is going to be unlocked, and so we can say that we have successfully locked and unlocked the mutex without issues. Now we need to lock the texture by doing stl lock texture. So to lock the texture, we're going to say app window texture. So this is the texture we want to lock. I want to lock everything, so I'm going to specify null. Now I need the uint. Okay, I'm just going to say void star pixels, because what the hell not. Make sure I save that to null pointer. And now I could access the pixels here, and I also need the int pitch, alright, which I could set to 0 here. And then if you check, we're going to have a reference to the pitch. Alright, let's remove this to make sure that works. Now SDL lock texture should return an integer to determine whether it was successful. So we could check if we want and say if result is less than 0, then I'm just going to assert false again, just to make sure that the line is printed out here. So instead of using a board, I could just use assert false. Anyway, I think that is pretty much it. So now we have to copy the data, and But before I copy the data, I'm actually going to omit copying the data right now because I want to test something out. Alright, I want to see, I want to compare the pitch of the SDL texture and the pitch that is given to me inside of the frame. So I'm going to print F, and so I'm going to say here that AV pitch, this is FF pitch, and then this is going to be, and SDL pitch. So this is going to be the FFmpeg pitch. You can find that using the out frame line size at 0. Yeah, I believe that's it. And then you can do the SDL pitch using the normal pitch as we had here, or as we have here. I believe the pitch shouldn't be too different from each other, but they will be different because of padding and stuff like that. But here I'm just going to do SDL unlock texture to make sure that I don't have any issues at the end of the day. And there we go. We have our app windows texture. And now what we have here is simple. We've now done this. We haven't copied the data yet, so we cannot remove the comments. We're going to do that right in a minute. So I want to add something else. So we're going to stop this thread from continuing to run when we close our application here. So how do we want to do that? Well, we're going to do that in two ways. We're going to do that, we're going to stop this thread when we finish decoding, or when this thread, which is the main thread, actually signals to this thread to stop. And how can we signal to the thread to stop? By using this atomic, we can use an atomic boolean, for example. Alright, that's what I'm going to use right now. So I'm going to say stop, right? And if I can remember, I can include atomic, and that should give me the std atomic bool to be able to use inside of my program. Yeah, there we go. So we have std atomic bool added, and now we need to set the atomic bool. So inside of our init window, we're going to say that app window stop is false. Now we don't want to call detach anymore because we're going to join the thread here. Alright, so what we're going to do is when we want to clean up, we're going to say app window stop is actually going to be true. And when that is true, we're going to do what is it called? App window thread.join. So what this is going to do is it's going to wait for that thread to terminate and finish, and then you can join us right here. And then we can terminate every other thing as we expect. So now all we just have to do is we're going to check while this and stop, non-stop, right? And we don't have stop, so we're going to do app window stop just like that. And so this is going to allow us to say, so while we're able to read a frame and we have not been asked to stop the application, then continue doing your stuff. And let's just test it. We've written a lot of code, so let's just test this to make sure that it still works as we expect. First of all, that we don't get a compile error. We get a compile error because we haven't linked the swscale library. So once we link that, that linker error should go away, and now we should be able to run this and see that it says here that we have bad destination image pointers. So let's make sure that we fix that. Alright, so swscaler didn't like the destination image pointer we gave to it, so that is one thing we need to fix. So what did I do here? Outframe. So we said destination So the destination. Well, that should have worked. What the hell? Well, I didn't print whatever I got from this outframe. I guess I'm just going to do that. So I'm going to do printf so that I can get information about the frame. Frames data. So out frame data, just to make sure that this actually is valid. I guess I'll check the first index. Also width, cd height. So checking out frames with out frames height. There we go. So now we're just going to compile again, and we're going to run, and let's see what we get this time. Okay, right. So frame data is actually null, and we got width 0, height 0. That's interesting. Alright, so that must mean something. That must mean that AV frame copy props didn't work, unless it actually did. I'm gonna change this to just the frame to get the frame data out of it, to see if the frame actually contains something before actually taking a look at the out frame. So here, this didn't work, right? Let's just check. Compile again and run the program, and from what I can see, we have some size for our frame. So frame actually works, but it looks like AV frame copy props didn't work. Alright, so I'm going to set it manually, as I wanted to do earlier. So I'm going to say out frame width is equal to frames width. Out frames height is equal to the frames height. And now we should not get that error anymore, but I found some other error that I want to check out. So now if I run this, let's see, do we still have errors? No. Now you can see now that the FFmpeg's page is 2880 and the SDL pitch is 1280. So I don't know why the pitch of this is so different from this, but I'm gonna pretend like I didn't see it. Actually, can I even do that? Yeah, I guess I could. So what I'm gonna do now is I'm going to do memcopy, and the destination is going to be the pixels. The source is going to be the out frame data at 0, and the number of bytes to read is going to be the out frames data at I don't know. It's going to be line size at 0. Of course, I don't know what's going to happen at this point because SDL is returning a pitch that is really small, but I think I'm probably going to need to multiply that by the height or something, but let's just figure it out and see how it goes. So now we're going to run and let's see what we get. If we get an error, we don't get an error. Instead we get a double free or corruption. Cool. Alright, I think I'd rather just say let's see, pitch multiplied by, we know the height, right? We know. Oh, I'm actually forgetting something important at this point. So remember that I think I need to comment this out. I forgot to do something here. So when I was creating the texture, I said that I was going to reset the size here, and I forgot to do that, and that might be a problem. So I'm going to come down here after creating FFmpeg initialization, and I'm going to set it to whatever the app window codec context width and app window, Codec Context, height. So this means that I'm going to be setting the data to this, and yeah, I'm going to be setting the width and height to whatever the video size is now. But now I need to also do this to make sure that I only set that after I have initialized the texture. So let's see what gets printed out now for the pitch. I believe the pitch should be different now, and it should be really similar, if not the same, at this time. So we can now see that the pitch is pixel perfect, and we don't have to worry about them anymore. So there we go. And the next thing I want to do is to just copy it, I believe. 2880. However, is that the size? I don't know. I'm just gonna copy. I think I have to multiply that by like the out frames height or something, but I don't always remember. So we're just gonna try it and see if I remember it right. If I don't, of course, we're gonna fix it. So we're just gonna mem copy this. Let me take out the comment. So once we mem copy that, we're gonna unlock the pixels and everything should work. There we go. That is beautiful. And now you can see that we have our application running. Now, of course, you can see that the resolution isn't good enough, and it looks like we just have one screen here, but that's not true. I'm going to try another video just to make sure that if you can see something that is moving around on the screen. But I think the first thing I want to let me verify that this video actually does have anything that like animates in the first like 5-6 seconds. Hello guys, you're welcome to. It doesn't look like it has anything that animates. Like, I'm just gonna mute the audio. So it doesn't have anything that kind of like animates in the first few seconds. I have like a Dart crash course somewhere around here. Where the heck? Okay, this is an interesting one. Where's my Dart video? Okay, it doesn't live here. Which one can I use as an example? I'm gonna check this one. Hello guys, you're welcome to another. So I move the mouse around like in the first 5-6 seconds. So I'm trying to find a video that does some kind of animation that you can see, so we can know that the frames are actually getting updated. But it looks like most of my videos actually talk for a couple of seconds before I start doing stuff. So here, maybe I'm just gonna take this one. I don't think I really spent too much time, So we're gonna go back and change that. We're gonna go back here to where we do the path thing. Here, there we go. Now the next thing we gotta do is, so we're testing. So I'm just going to compile this again, and then we're gonna run this. Okay, and you can see that of course it doesn't look as good because I'm going to change also the size of the window, so it's not going to be 640 by 480. I'm sure that's going to make a difference. So if I go to, where is our init window? So here I'm going to do 1280 by 720. That's a little bigger, so we're going to do that. There we go. Now if I run the program, you can see now that it's a little bigger with a little better quality, and of course probably has something to do with the fact that I use the RGB 565, but it still looks good, to me. And I just want to figure out if, you can actually see that this is actually working. So you can see that right here. Now, something else that you may not have noticed in this video is that I haven't implemented anything that looks like timing. And any frame. Whoa. Bad idea. So I did somewhere. If this is ever going to let me fix it. Anyway, we're just gonna wait because I cannot restart this recording. There we go. Come on. Right, so it looks like I have some memory issue here. Alright, there we go. Right. So it looks like I have some memory issue. It's kind of expected. So let me see. While I read the frame, I basically just read data inside of here. And I unlock the texture. But what do I do with the data inside of this out frame? So maybe AV frame ref could help me there. Out frame. And also here, I should also do an what is it? Yeah, we should also do an AV frame ref on this frame. What do we have? So I just did so you should do an AV frame on ref to actually free the memory associated with this. And I don't think I'm leaking any more memory. I can figure it out. Yeah, also the speed at which I'm actually decoding might also be having some impact on the performance of the application. So I'm going to slow this down a little bit. So once I do this, I'm going to do an SDL delay, which is going to be like 30 milliseconds again. Now this is a really bad idea, by the way. So generally you want to decode your audio, your video frame inside of some sort of buffer, to catch like 2, 3, or 5 frames that are ready to be sent, to the display when it's time to render it. So that way you can get ahead, in like a few milliseconds, and you're not gonna be lagging behind. But you can see that in this video I haven't really addressed anything like timing or PTS or things like that. And it is something that I wish to take care of in the probably next video when I talk about FFmpeg again. I'm going to show you how to take the last video, which was the audio tutorial, and this video tutorial. We're gonna take both of them together, and we're gonna create a complete media player application that can play both audio and video at the same time. Of course, complete with synchronization. So let me just see if I can run this again, and if it's not gonna glitch out on me again. This is of course another gamble, so let's test it. If it gets to compile at all, and we're just gonna see. And let me just use that opportunity to see if I don't have any memory leaks. So what am I doing here? Okay, true. Maybe packet ref. So take away my packet, and yeah, there we go. Ref the frame. Ref this frame. We're good. Anyway, let's just compile it again. I don't think I have memory leaks in there, but who knows. So now let's run it again and see if we're gonna crash and burn again. Okay, here's our window showing up, but we haven't seen anything, and we crashed. Okay, so why did we crash? It says failed to submit batch buffer, invalid argument. So I think this has something to do with the texture, all right? And the fact that we're actually rendering the texture on another, on another thread. So ideally, we're supposed to submit the frames to, like a buffer, and then from the main thread, we're going to read the buffer inside of the texture and then render the texture, as simple as that. But anyway, now you can see that FFmpeg is not rendering as fast as it was before, but now everything still works, and it looks like the video is synchronized even though it is not. That is because this video is actually taken at 25 frames per second, and You know, right now I'm just slowing down so that it doesn't use up all of my CPU, you know, with the delay here. So before, the decoding was really fast and it was just using up all of the CPU as it can, but now it's just going to wait for some time. This one is also going to wait for some time. Where is it? The delay here is also going to wait instead of just, you know, looping and spinning forever. And now this works. So I believe this video has gone on long enough. Thank you guys for watching. I hope you like this video. Please leave a like and subscribe, turn on the notifications, and I will see you guys in the next video. Bye bye.